Learning that I'm live. It'll probably take 30 seconds or so. So, the goal today, yeah, maybe, right? Live. Oh, I'm already live. Learning that I'm live. It'll probably take 30 seconds or so. Yeah, so, the goal today is gonna be to, there's two things. I think the first thing I want to do is like just look more into the task and kind of plan out how I want to do the chinchilla thing because that is like the goal, right? And then I also need to program the mixture of experts. But because I have like a working thing that I can actually iterate on, uh, I think it'll be more fun to do some iterations right now since I've just been doing a ton of building. And then after that I can go back to doing more iterations. Right. Jax catch. This was one thing I looked into yesterday at the end, but I didn't do it. Yeah, I think I can just literally do this. And this should hopefully like make it so that pal times are shorter. And so I just did something like this, but instead what I want to do is use the same model. I think A layer is probably overkill. I think A layer is probably overkill. Based on what we saw yesterday. Anyway, 4 layer. I'm wondering if I can cut things further. Like I should just try it out, right? 64, 256. That might be crazy. This might be am I at now? My estimate is off the top of my head would be like, which I don't remember what it was previously. I'm just gonna multiply. 4 times wait, what? I just okay. 4 times 64 times 256 plus 8 times 64. It's like tiny. 3 times 3. No, this would be 4. I did that. Okay, yeah. So a quarter of a million. I think I can probably do it in a quarter of a million. Like, there's no need to stick to using that number. Um, Instead of 3 digit, because that will hopefully like increase the demands. But frankly, yeah. So I'm gonna as soon as this is able to connect, I can write out my plan directly in the repo. Connect to hosted rent. Let me refresh. What? Failed to execute cell. It's fine. Import Jax. Let me run this cell first, just in case. Why? Okay. Stop getting frustrated. Hmm. Connect to Google Drive. Yes, please. Continue. All right. Dun, 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 dun. This is not normal. All right. Well, it is already mounted. So, I mean, like, I guess it's fine that it disconnected now at all times. Google Collab. always disconnect. I didn't really address this. It's not the captcha issue. Okay, but that didn't cause any errors, and hopefully what this does is speed things. Right, so I wanted to create a plan, um, which is basically focused on, let me see, let me look at plan one. Create the data set, create a baseline model, confirm it trains. Find a good config. Yeah, so basically what I want to do is find a stable batch size and learn. I probably need to do some learning rate sweeps. So do some learning rate sweeps and on a model. God, this is really bad. Find a model size where there is notable capacity differences. It's also zero, given how kind of simple the data set is. Like if it can't reach loss of zero, it's just not a capable transformer. And it's probably not going to be useful for the scaling study, but what I want is to find a level where like no matter what I change the learning rate to, this model takes more tokens to reach loss of zero, I guess. I guess that's the scaling study, right? The other thing is because we're dealing with a fixed point of okay. So chinchilla laws is usually like laws for chinchilla. Chinchilla laws are usually fixed, yeah, based on what I learned, right? Fixed compute budget. How can we get the lowest loss? Right? Is that true? Uh, given that this task is accuracy 100%, maybe my law should be on a fixed compute budget. What is no, because fastest is always just going to mean largest in that case. Give yeah. So then, if loss is floored, it should be what is the lowest compute budget I can reach 100% accuracy with? Like that would be the task then. And that's like different from chinchilla because um there's a set point, right? That's the issue is that there's a set framework for goal. But yeah, we have to first do this stuff first. Um, LR is equals 2, 1 negative 3, comma, 3 negative 3. For LR in X. I think keeping the batch size at 1000 is probably fine. So there's my sweep then. Um, let's get everything on the same. So we have what? df equals to pd dot data frame accuracies of zero. Sure. Um, maybe what I want is to store just train. I'll just do Vala. I won't care about train. It's fine. df of um so I have a list of dicts, right? How can I do this? Huh. Pandas data frame. Add column from list of dictionaries. Okay. Something like this. df equals pd dot data frame. Accuracies of zero. Index. Mm-hmm. Something like this. df of uh, new df equals to p dot data frame x. I don't know what I want to do this. Something like that. Yeah, something like this should work. For like very, very slim baseline. Let's just go ahead and run it. Since this will take a little bit of time. Oh, and hopefully the jig caching works because that would make this a lot faster. Look at what this actually does. Let's also check TPU. Using some high bandwidth memory. It's more than the data said, which is like a lot. Usual, as in yesterday, more than yesterday. Okay, well, it's running the first one. Oh, notably, it's a lot slower. That's probably a good sign, and the learning rate is also low. Okay, this is the next one. Weirdly, it starts so high for Val. Yeah, so I think the caching worked, by the way, because they compiled very fast. You can see like, oh, so the learning rates earlier were too low. And now these learning rates, which are higher, conversions, and maybe like learning rates that are too high will lead to like some weird overfit behavior, or like weird like unable to converge smoothly behavior. Cool. Okay, this finished. Not sure. PD dot data. Index data must be one dimensional. See. Step, step, step. Okay, okay. Okay, so we have a clear winner here. What's X and Y? Oh, x 0 y. They're identical. I'm not gonna worry about it though, 'cause this is definitely the first one. So what's the brown one? That's 4, right? So that learning rate was way too. Okay, so the best learning rate was. Should we do one more sweep? Let's do one more sweep. 500 max steps this time, and we'll do what? T negative 3. The other thing is I want to log it a little bit more often. Should be cached. Maybe not. I mean, the bar hasn't even shown up yet, right? So that indicates what? We also have this interesting behavior. It looks like the double the same, but it could just be, I don't know. Is it done? Uh, wait, this is interesting. So, okay, yeah, the 0x behavior is not good. Why is that happening? Index equals 0. Oh, because it merges them early. Shouldn't do that. Anyway, we see that we're actually able to get even faster convergence. What? Why is this so bad though? Yeah, okay, 3, -3 is just the best learning. Okay, okay, okay. Fifty. Um, and now I guess I'll try with even smaller models because this is like ridiculous. So what? I'm gonna go down to 2 layers for this. I'm not even sure why that happens, but what the hell? Mm. Yeah, maybe better introduce. It's like- I'm not using the 1 dB. That's like unnecessary with this kind of pace of change. It's like doing too much. I'm actually surprised at how much of an impact that should be done. Yeah, the other model also trains quite fast. Let's disconnect it. Now it should work, right? Okay, well, here's the results. And the smaller model just trains faster. Okay. By this point, it's only seen 200,000 examples, by the way. And it's already able to generalize, which is it's pretty cool. But yeah, I'm gonna change the way index is done. So index equals to um, uh, model index equals to 0 to LR index equals to 0. What I'll do here is just do LR. So I said you're so right to myself. Okay, anyway. So I'm not gonna look at this one anymore. It's just not up to par. The only thing I've been doing is keeping batch size fixed, which I think is fine, but something to keep in mind. Um, I guess I'll test out a 1 layer transformer, and then I'll also test out reducing this width to 32, set f to 128 then. And we'll cut the number of heads in. So some different stuff. And we'll do a learning rate sweep of what? Number four. So yeah, it's better to be at like that five. Why is six so bad? That's did I misinput? Oh, that's why it's so bad. I didn't realize. Anyway, I do what? 3 negative 3, 5 negative 3, 7. So it'll be a 3 by 3 grid. So fast. This is for my music. It seems like everything learns. This one learns extremely fast. The one layer. I think the other thing is that the fixed position of everything. It means that an MLP could easily do this. But it's mostly fixed regardless, right? As we discovered earlier. So it was. Hold on. Why are the? But I said index here. It's not good. Oh, it's a comma, huh? It's literally more efficient for me to just reach it. Let's like try to parse through this. Yeah. So I could remove the position encoding. Is that really fair though? Then the model would just be guessing, right? I don't know. Like adding the spaces again doesn't change much. Okay, so the fastest training one was this one generally is very fast because yeah. Uh, gotta go. We're not gonna find any meaningful laws just doing things like this. Change the equation too much, actually, considering what it is. Um, is there a better way to format this that's using a one layer transformer feels like defeating the purpose, and definitely like an MLP probably could do this. Um, hmm. I can try to scale down the one layer one even further. By the way, which one did the one layer one do the best on? Okay, for perform the better on the interesting middle learning rates. Yeah, try with just two heads. The takeaway is that it did better on the higher learning rates in general. But they're kind of similar, so it's probably fine. Looks like we're finally seeing some level of drop off. La 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 la. I want to see the train loss by the way. We're disconnected from the runtime right now. Okay, so at the very least, this model couldn't train, and this model was a lot worse. Try a wider range of learning rates, right? Just in case. So keep this. In general, what did we see here? The higher learning rates helped this one, right? So we need to try more higher learning rates. 7 negative 3, y negative 2. This should be good. Also, how fast are we learning now? 100? That's enormous. How big are our models now? Like our smallest model is so tiny. What? 3 times 16 times 64. Yeah, this is like an tiny. Okay. No, but okay, wait. The takeaway from the chinchilla studies was scaling. I don't know. TLDR. But that doesn't add up if it saturates. Chinchilla scaling loss, saturated loss. It seems like the learning rate was still not high enough for this model, but it could have done even better. Well, and this one does best on what's that? Red is this. Oh, brown makes it two worse. Okay, so this is just under capacity, or it'll take longer. Right? What does it reach for training? Why don't I track trading losses there? Yeah, because this is just kind of showing which learning rates are optimal, right? And they all kind of saturate. This, which is weird, indicates maybe, I don't know, some instability, but it's not like a huge concern. It's changing my music. Okay. Uh, I'm not sure what this implies. Because the data is very largely homogeneous, right? And it's not like it's exploring anything unique. Um, oh, I could add more than one three-digit number. I think that could be pretty cool. To open this in incognito because I'd love to read it. Um, what does he do? What kind of model does he use? Model. WinGPT model. What config does he use? Any notebooks? Demo that. Yeah, this doesn't have outputs. Um, like this, it does sound like. How does it encode the digits? Generate a data set of simple up to three-digit numbers. Generate a data set of simple up to three-digit numbers. Right. Let's see. I could do something like this. One third of the examples that I give to the model will be just two numbers. One third will have three numbers, and one third will have four numbers, something like that. The other thing is, it may be better to generate the data set on the fly in that case, or generate each batch on the fly. Actually, I could just make it be four digits always. That's fine. Or four numbers. Oh yeah, chinchillas. Yeah, I'm gonna look into this even further. It's a Google. This is some AI generated stuff. I like geeks for geeks. I don't know what this nav bar is for. Okay, so Here's the idea. Choose a flops budget. Okay, so you choose a flops budget, right? Um, you have model size. You have number of tokens, right? What is that graphic? I think it looks something like this, right? This is one flops. No, as model size increases, it's like something like this actually, right? My graphing. I'm graphing a certain flop span. It looks something like this, right? And now for this budget, you can like do this, 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 and you see what are the losses after a fixed amount of time. But you see what are the losses at their respective token budget. Okay. Um, I'm doing everything in B flip 16, right? How many flops are used to train the model is product of. Okay. So let's create a chinchilla.py then. Def get and token budget from params. And what params will take in? I'll take in all the model params, right? So what are the model params we have it here? L E F E H T, right? So the model, um, this is what I actually care about, right? Calculate model flops per token. wait, model flops per token? Sure. Uh, no, I don't need it. Flops per token is what? Training, right? I need to be careful not to hum. I don't want my YouTube to go away. Okay, yeah. So L times 18 plus 18 times D times F. Actually, on BT, right? Plus 24 times 12 times T times. No. Per token. But this is like T as in like, yeah. 6 times. Like, wait. Because my sequence length is 12, right? You need 12 times 12 times N times 8. Like, it could get big, but if I'm using that as H, then D is gonna be much larger. So I should just be able to ignore that. Um, Batches. I can just limit by batches. It's fine. Flops per batch. No per sample. It's fine. Times T plus 12 times T times T times N times plus times D plus 12 times. T times J times. Actually, it's gonna be larger than anyway. Calculate model flops per sample. Calculate sample budgets. Maybe worthwhile using even smaller batch size, because I don't know about how granularity is going to be here. Yeah, because the best like plot was like this one, right? Training loss versus number of parameters. And then it showed like different token budgets. No, these are different flops budgets. What are these? These are not flops. Given C, fixed amount of compute, right? Such that the flops count remains constant. Right, this is what I want. That's gonna be inverted for me. That's fine. Okay. So I'll probably have to invert. So the chinchilla pipeline is gonna look something like this. Just declare a list of models to choose final loss models. They use like a so I can honestly like do something like this, right? Um, Maybe it would be nice to have one bigger than this. This bigger is kind of expensive. Yes. This is scales with both the and F, right? Maybe something like 48. It's 6 hands. And then 48 times 4. 6. Oh, wait. If x equals 10. Uh, sounds like anything. Is this right? Why can't I do this? Wait, is it because it's not like connected? Okay. Let's. This is freaking me out. Bracket was not closed, right? But it definitely is. It also says this one is not closed. What if I just ignore it? No. 38, 196. Oh, why is this 8 dot? Ah, that was the issue. Wait. Anyway, 48. You have 32. It's also just 224. This is 120. For this, I reduced the number of pads, right? We'll just stick with this for now. Um, 4 models. And then we'll look at L equals 2, CF0. Okay, so now we have four models. You can clean this up later too. Budgets, flops, budgets, budgets, from chinchilla, import, import chinchilla. Budgets equals to example. This variable. Yeah, something like that. Um, these are the sample budgets. Um, I should also get like final last rule. It's fine. Um, so what I want to do is maybe train at like the number of, well, actually no, I don't even need to do that. I know that the number of samples that leads to like this step, which is like a decent step to look at, was 100,000, right? So all I need to do is multiply 100,000 by this model's config. So this model times uh, 18 times 32 times 128 times 12 plus 24 times 128 times. Hold on, is this? Yeah, that's 24 times 128. 24 times 32 times 4 times 8 times 12 plus 12 times 4 times 4 times 8 plus tokens E plus T and E. What am I saying was T and D? Anyway, that was times one, right? Plus 12 times. um, 12 times 12 times d, which is 13 times 3. 13. Oh, wait, sorry, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 13 e10. Hmm. I need to do a grid of LRs, right? I mean, negative 3, 3, negative 3. Okay. Budgets. Batch size equals 1,000. I'm gonna change this to just be. It's fine. It's fine. There's no compute constraints. Compute constraints are not real. He said doing as compute constraints. Like, no, as in I'm not a compute constraint. Um, time is gonna be not an issue. So what I do, and models goes to like the models where I in range of m models, something like this. So for LR and LRs, final losses equals um just go with this for now. Where did I got lost? Okay, final answer is this, right? For LR and LRs, um, train state equals trainer dot initialize train state model random key models of Batch size, 12 solution. That's accuracies. This pattern and be string. Okay. Budgets. And then this will be batch size. Accuracies, right? Final losses dot archive of -1 loss. Yeah. So this best losses dot archive min of final losses. Just be okay. So hopefully we can get some interesting results then. And let's see where our errors are. That's fine. See, it's not where C and model is not be interpreted as integer. It's training. It doesn't even, yeah, it doesn't even get to 200 steps, which is fair. For the tools. Yeah, we're only going to see the first steps, but we saw that the first model is not done. Just, yeah, I think I maybe choose models that are too big. Which is okay. Wait, no, I also chose like a really small thing. So it's fine. And I chose, yeah, so 5 different LRs per. So we should be on the third set of models. The third chill vibes. Okay, it's done. Let's see what they are. Okay, so the smaller models are just better because the bigger models don't get enough training. Now let's see if how much smaller is better. I think this is good. I should also actually store bestseller just in case like I can save. Final losses equals this. Right. Um bestseller. I think it's just arguing. It's- Yeah. That's a quite a significant impact. I want to see budgets. This one sees like 100 more. So this one only gets 26 at 26 training sets. That's not nearly enough, right? I don't know what we're What's going on here? I forgot to stop pinching. Just doesn't have enough steps to learn, right? Is my thought process. So, um, it's doing too few steps in that thing. Is the main issue. Okay. Yeah, this is quite difficult. This is it's just a matter of optimizing steps, right? Chinchilla paper patch slides. The standard patches of top one. And we got something, right? This is like pretty interesting. Now what I want to do is reduce the patch size. And we'll see what blows up. Re-input this. Just not use it. But using a batch size of 100 could lead to like a lot of variance in that. Still be fine. 100 is still reasonable. You get prints at the end of each model. Really not going to get good TPU utilization. It's going to be like tiny. 34, 15. Quite interesting actually. This one's better with a different best LI. We might be constrained in the LI. It's going to be this. And this one gets like nearly golden. 5 models, right? So the question is, do these models have the capacity? I assume they do. So it's very similar. But it also might have saturated. Should probably return this. This is the chinchilla. Wonderful. It's like the LR grid is covering most spaces. That's good. There's probably some other configurations. Okay. So it seems like this batch size is reasonable. What if I do like 3? This one only gets 6 compared to 200 for. Uh, but that's just the nature of what I'm doing it. I can't go lower than 100 batch size without sacrificing something else. This is here, yeah, it gets 200, which is like the second. Not getting good either. Okay, that's really interesting. So this loss is very similar for these two. June 98% accuracy. So this one nearly saturates. Pretty much does saturate, right? Is that they saturate? Losses are higher, which is good. Might also be LR gated though. Like if they had a decay, they would be able to. Um, it's not a pleasing results. Especially with the learning rates being so high. Seems like it's just having trouble settling, most likely. How do I address that? That's such a pain. Anyway, it's still saturating, right? So let's get this. Let's get a good one. Uh, Because no matter what for their one, right? It's not a question of like, oh, it didn't get enough optimizer steps. Like constrain flex too much, it just becomes a question of who gets. That's 100. Basically, I want to reduce the flops budget. I want to give the big models a fair shot. Let's just try it. For the Optimus systems. Let's just see. Now all the trainings will be 5x quicker, allegedly. Can't train anything because it doesn't have enough steps. That's fine. Yeah. Steps are down, huh? That one got 150 steps. So yeah, that's man. Everything is out of control. Let's try to mention it. They just don't get enough optimized. That's about 150. It's just the golden one, huh? Best at any budget. Let's make it a little more granular. I'm not even making more granular. They only come down this. Maybe like but instead of 24, you have 20. Something like you don't even know if these are ordered in numbers. Let's check the budgets. Budgets increasing. That's an increasing. No, except for the, the third one is a low. I think there's still some low. Some of that pretty good. And for a parabola, the second model sucks. third model is extremely good. The fourth model is even better. What's with Model 2? Sweet. Kind of parabola-ish. It's pretty constant over here. There's at least a little bit more. There's some consensus on the best LR, so I can constrain this. What's up with you? What if I just keep these constant? And only differ in this dimension. So just like count on Netflix. So a lot of these should not change, right? Some of them should. A lot of them shouldn't though. I'm disconnected. Seems like I need lower LRs. And then the last one is just weirdly good, right? I think it's just too unstable at this stage. Okay, so we'll do the following then. Just the um Dash times 10. It's not gonna solve the issue, but it might solve part of it. Yeah, we really duplicate the monster at the end. It shouldn't be a big deal. Final Val badge. Nice. So any syntax issue also. Okay, so this looks like grasping at straws because the real issue is that training is just unstable. It's such small things. So I can do this. Do batch size 10. Maybe this is 100. It's gonna take a longer time, but this may be the solution to get things to be very stable. I should probably reduce the waiting list time. Maybe it doesn't take more than a minute per model. Final train metrics. That's a thing. This should be fine. was the first one? So it's about a minute per model right now. So area so much. I feel like I'm latency gated, you know? Not even like comps, like literally like it's just gonna be latency because of how many batches I'm running. A minute per is kind of bad. Reconnect, please. Yeah. Understand? No, it isn't me. I don't know, it doesn't mean much. Why is the one with lower loss having me something like that? Only because of the weird flash size maybe. No, it doesn't make much sense regardless. Spend that 100. Why is this higher? Batch. I should do something else. It's kind of cool, but at the very least, we know that like we need a setup. I don't know. It's still super unstable, isn't it? I want to avoid having to train like a bunch for anything. Batch. It's too. -3. Anything like use of the second list? very fast here. And I want to move a small model. Let's see the budgets. And it's still dominated by multi size, right? Indeed. Uh, would there be a way to speed up while keeping the batch size super low? Probably not. This is gonna take about 5 minutes. Let's go ahead and look into how do you create a mixture of experts model. Router, selected experts. Still saturated. No, it's fine. Either do that's just a different MLP. It's suit, but I wanna work on the ML. Sense MLP. Okay, so how does it just use different MLPs every time? Oh, okay. So it's not about the MLP. I don't know what I did. Traveled in time. Blueprints. I don't know if it's gonna. It doesn't look like it's gonna bottom out. This one had around 99%. Ah, basically, I want to color block. There's like a question about deep sleep. Have e-copies. Yeah. So it would essentially be like a, huh? There's something here. Yeah, this is my scaling law. There we go. Okay, so I can get some level of chinchilla going. Now, for example, what if I constrain compute to no? So now it's like a really tall challenge, right? Like these guys also only get like 40 steps now. It's pretty insane. That might be too. No, they get 400 steps. What am I saying? Because that's just 5 steps. Batch size. Smartly, I changed the batch size. Alright. So basically, what I want to do. So now I don't store just W in one. I have to store this for every expert. Um, I just can't, right? I don't know if anyone can, which is fair, because they don't see enough data. This guy actually gets up to 70% value, which is quite good. I still learn. Smaller models do a lot better now, which is quite cool. try that. And then I'll just increase my mono grade. It's fine. Yeah, that should take a little longer. So basically what I want to store is I need to make a E by D by F matrix. And then I need to have a different MLP forward, which does the routing inside of it. Or I could do the routing. Different MLP forward. Okay. Off that. And I disconnected again. So it's just. I'm. I guess I need to eat lunch. I'm getting too frustrated. Let's keep it to myself. Not to break. No, not this one. I don't want to edit this one. I want to edit Emily decoded. Right. Um, I also need to tell it what my K is, but I also need a router. What's my router gonna be? Um, we did MOE before, but it was focused on like what happens after MOE, right? Yeah. Or like Uncharted, but it didn't focus on the plot strength. It just focused on the Uncharted. Interesting. Wow, smaller models are just too good. I just hope we got a model small enough to where it just can't, right? 6 long. It's not too many. Like 2,500 is still a lot. It's not 5 times. How many models did I have? 5, 6, 7, 8, 9. Yeah. Okay. So I'm at, that was one of 8. Well, it's extremely good. Higher than it's can cut off the last. You know, 5, 7. It's not, again, this is just like a. I mean, once I have this kind of experience of running it, um, the next time it should be a lot faster. It's so good. What? So I need to get even smaller models? Is that what you're saying? No, I think the actual law I'm discovering right now is that there's a certain minimum number of tokens the model needs to see to learn anything at all. And as long as it sees those minimum tokens, your tiny models can do really well. Because the task is just extremely easy. I mean, it's not like they're learning it perfectly though, but they're learning it enough, right? Because they've seen enough kind of token, kind of sequences. I'm trying to do different types. Ah, that's my good. Self-done router. Yeah, you have a router. No, I'm not gonna do that. It's